Hi, hello, good evening, one and all. Welcome to the session. Please let me know whether this audio and video both are clear or not, and just give me time. Within no second, I'll hello, my dear. Can you tell me, is that everything is clear? Good evening, Raj Pandey, Ritam, Anita. Good evening, everyone. Is everything clear? Gayatri, clear means not clear or not? Let's see, sir. Let's move it very quickly. Anybody, have you tried yesterday's homework question, sir? Anybody tried homework questions? ऑडियो वीडियो क्लियर है ना? तो आज का सेशन है, हम डिस्कस करना वाले हैं स्टार डेल्टा ट्रांसफॉर्मेशन. वी आर गोइंग टू डिस्कस अबाउट स्टार डेल्टा. Much before that, in the yesterday session, I just finished only KCL and KVL. We have to discuss even the nodal and mesh. So after that nodal and mesh, we'll take up at least we will try to take up three problems on nodal and three problems on mesh. Then we'll move on to the star delta transformation. Star delta transformation is just a small technique, sir. Right? So it is a part of analysis. It's not going to be the special topic. You cannot treat it as it's just a part of analysis. Okay. So let's move on. Before moving on to the session, let me introduce about myself. Those who are very new to the Gradeup platform, Gradeup White YouTube channel. Myself, Naveen Golapalli. I have around 7+ years of experience in teaching. Most of the times, I'll be teaching machines mathematics, right? And by a very good book, I can say. No, this is in this book there are around more than 22 chapters are there. He has started from scratch and he has taken to the next. I can say this is a very good book and one of the fine book I have ever seen. You just go through it. My sister advice: if you have time, you just go through it. Right? Those who wanted to start network, right? Now in my channel, not only about study material, you can post your questions also. By the way, you can post your questions and doubts, right? And so that I'll try to respond. I'll give the response. You just tag me. I'll try to respond. I'll definitely respond to you. And this is much more details about these courses. You can call to this contact number, right? If you have any doubts or if you have any queries. So let's start, sir. Let's start and let's get into the session very quickly. No audio? Since long time no audio, no video. No audio or no video. Is it clear, sir? Audio, video, दोनों clear है? Audio, video, both are clear or not? Video is okay, no? No audio. From my side, it is clear, sir. I think from my side, it is clear. Can you respond, each and everyone? Please respond, sir. It's okay. Sound is little bit low. I'll adjust. Let's move on very quickly. Both okay now? Anybody have practiced this one, sir? Anybody? Anybody tried this one? Yesterday I have given this question. If VA minus VB is 10 volts, then VC minus VD is VA minus VC. Potential difference between A point and B point he has given as 10. Okay. A is at higher, that is positive terminal, and B is going to be negative. So this is my 10 volts. If you know the voltage across any branch, and if you know the branch resistance, you can calculate the current or not? Or no? So 10 divided by 2, you are going to get it as 5. Right? If you treat this entire left side branches all together as one circuit, and if you treat entire this right side branches all together as one circuit, so I can say that circuit A is going to deliver 5 amperes to the circuit B. You name it as circuit B, and if you name it as circuit A, circuit A is going to deliver 5 amperes to the circuit B. Whatever the current which is drawn, or whatever the current which is accepted by the circuit B, has to give it back to the circuit A. That is what KCL, right? Kirchhoff's current law, law of conservation of charge. Whatever the charge which comes to the node has to leave the node, right? So let me so C terminal is going to be negative and D terminal is going to be positive. Now I can write the voltage across these 2 points is going, of course, no need to write minus because I have already represented here. Or no? Is it clear for everyone? Can you respond in the comment box? And try to share this session to your friends also. Try to share this session to your friends also. Like the session, by the way. 7 volts. Voltage across C and D terminals will be 7 volts. Is it clear for everyone? Clear for everyone, sir? I think audio problems are getting frequently. I think so. So sorry. I'm so sorry. What is happening? Is it clear now? Can you tell me? Okay. Yeah, I'm Manorama. Each and everyone. I'm reading the comments. So audio problem is there. I'm looking into the software also. The audio is enabled. Audio is enabled. Now, is it clear now? Can you respond? Is it clear now? It's fine now. Hello. Let me take up once again. Control Shift E. Right. Shift E. Hello. We are taking much more time on the first question itself because of audio problem. I have changed location, so that's the reason why problems are coming. Anyhow, let me write. Let me write. He has mentioned voltage across A and B terminals as 10 volts, right? So voltage across A and B terminals is known. So 10 divided by 2 is going to be 5 amperes. I'm assuming this entire part as circuit A. I'm assuming this entire part as this entire group of elements as circuit A, and then this entire group of elements as circuit, right? So if circuit A is delivering 5 amperes, circuit B is receiving 5 amperes, whatever the current which is delivered has to come back or not to satisfy the KCL. Definitely, right? And whatever the current which is received by the circuit B has to deliver it back to the circuit A. So circuit B is going to deliver 5 amperes. If circuit A is going to deliver 5 amperes like this, now at this junction, 5 ampere is entering and 2 ampere is entering. So from this junction, 5 plus 2, 7 amperes will leave like this. At this junction, 5 amperes, 2 amperes both will enter and leave as 7 amperes, right? So 7 and 1 are going to get 7 volts. Going to get 7 volts. Is it clear now, everyone? So I can now say here the current leaving terminal is going to be negative. So this is going to be negative. C terminal is going to be negative, whereas current entering terminal is positive. So D terminal is going to be positive. The voltage across these two terminals, C and D terminals, is going to be 7 volts. Or otherwise, C is with more negative and D is with positive. VC minus VD is going to be. Can you tell me, is it clear now? Can you respond? Can you respond? Is it clear now? And please try to share the session and like the session with your friends. Okay, if you are very much very much continuous to this session, I'm damn sure it is going to help you the gate examination, the 80%, sir, because we have taken uh, such kind of topics only help you in the examination, right? Now gate is not a big tough task, sir. Gate needs is you need a continuity, a hard work. Hard work will never give you result. Continuity will never give you hard. Will never give you results. Continuity plus hard work, both need. Done. Let's move on to the next question. Can you look at this question? The potential difference between A and B. Potential difference between A and B. A is here and B is here. A is here and B is here. A is here and B is here. Is asking potential difference between A terminal and B terminal. If you are able to calculate potential at A point with respect to ground, if you are able to calculate potential of B point with respect to ground, you can find out the potential difference. Try to assign somewhere ground. Try to assign where. I'm assigning ground here. This is my 0 volts potential. Right. Okay. Now you might have gone through the nodal analysis. So nodal analysis is going to be, you have to do like this. First of all, identify the principal nodes. Principal node means, yesterday I said that there at least minimum 3 branches should be connected. At least minimum 3 branches should be connected. So this is a point, this is one principal node where 4 ohm branch and 10 ohm branch, 4 ohm branch and 3 amperes current source. Three branches are connected. This is a principal node where current division or addition is possible. Simple node, no need to go and no need to go for analysis at all, because current entering current will be leaving, will be equal to leaving current. Similarly, you see B node also. 3 amperes current source, 2 ohms resistance and 6 ohm resistance. These three are connected, so I can say that again is going to be present. Similarly, here also 10 volts voltage source, 4 ohm resistance, 2 ohm resistance, both are three are connected. So that is also principal. And here also 10 ohm resistance, 6 ohm resistor, 10 volts voltage source, three branches are, that is also principal. There are four principal nodes in this, four principal nodes in this network. So after identifying the principal nodes, what you have to know, what you have to do is take any one as reference node. Take any one as reference node. I am making this as VA potential. I am making this as some potential. I am making this potential as VB potential. This potential, I am assuming this as reference node. I am assuming this as reference node. Therefore, what is going to happen? Reference node, datum node, ground node, all are same. As you are assuming it as ground node, the potential is going to be zero. Potential is going to be. So after considering reference node, then look at the remaining three principal nodes. Out of these three principal nodes, how many node voltages are known? VA voltage is nothing but voltage across 10 ohms. VB voltage is nothing but voltage across 6 ohms. Now what about this voltage? From the ground, if you move, you are crossing 10 volts voltage source. That means what? You are gaining 10 volts. The voltage at this point is going to be 10 volts. Voltage at this point is going to be 10 volts. Right, sir? Out of four principal nodes, we know ground node potential, we know this middle node potential 10 volts. Only two unknown principal nodes are there. Now you need to calculate those node voltages. If you calculate those node voltages, you can calculate each and every branch current. If you calculate each and every branch current, you can calculate each and every branch power, you can calculate each and every energy consumption. Right? This is what nodal analysis, right? This is what nodal analysis. Very good, Hyderabad. Superb. This is what nodal analysis. Now, if you take up now, he is asking VA, potential difference between VA and B. So let me calculate VA. Let me calculate VB. If you are going to calculate VA individual voltages, apply KCL first, then convert into ohm. I am marking it as I1, I2, I3. So at node A, I am writing I1 plus I2 plus I3 is equals to 0. So remember, whenever you are writing node equation, you assume that node voltage is greater than any voltages in the network. Then only, if you assume like that, then only you can draw the currents, or you can represent the currents leaving from that node to the lesser potentials.